You know, when you head to the clinic or the hospital, your main focus is, well, obviously on your health. But right beneath all those clinical interactions is this massive, highly structured flow of information. Today, we're diving into an explainer on the core rules behind medical coding. We're going to unpack the rigorous, totally invisible language that's operating behind the scenes of literally every single doctor's visit. So, think about it. What actually happens after the doctor leaves the room? To find out, we've got to look past the actual clinical care and meet what I like to call the invisible detectives of healthcare. Yep, medical coders. These are the folks taking those highly complex narrative physician notes and translating the whole shebang into a strict, universally regulated system. Now, this is super interesting. Coders are actually often referred to as the fraud squad, and that really elevates them from being just, data entry clerks to elite translators who enforce strict national compliance. As you can see here, they optimize making sure everything legitimately documented is billed for, but they never maximize by assuming facts. Basically, if it isn't specifically documented in the medical record, well, it simply didn't happen. No exceptions. All right, let's jump right into Section 1, Tools of the Trade. And the main tool we're going to be looking at today is the massive, universally used ICD-10-CM classification system. Navigating this giant manual requires a pretty strict three-step workflow. First, you have to identify the main term in the doctor's diagnostic statement. Next, locate that exact term in the alphabetic index. But wait, here is the absolute golden rule. A coder must never, ever code directly from that index. You always have to verify the code in the tabular list. Skipping that final verification step, which is where all the essential instructional and excludes notes live, is pretty much a one-way ticket to major coding errors. Okay, moving on to Section 2, the grammar of coding. This is really the heart of the matter. Because just like any spoken language you or I use, medical coding has a grammar, a syntax, and punctuation that absolutely must be followed perfectly for it to make any sense. So the most crucial point here is that a code is completely invalid if it's missing even just a single required character. In this world, specificity is literally everything. These codes range from 3 to 7 characters. And a 3-character code? Well, that's only acceptable if the system doesn't subdivide it any further. But if a code does have subcategories that stretch out to 4, 5, 6, or even 7 characters, the coder has to assign the code to that absolute highest level of specificity. You can't just slap on a general 3-digit code if a highly specific 5-digit version exists that perfectly describes the patient's condition. Which actually brings us to one of the most fascinating quirks of this entire coding language: the placeholder X. Sometimes, a specific category of codes, like the ones for injuries or poisonings, requires a 7th character to indicate, say, whether this is an initial encounter or a subsequent one. But what if the base code only has 4 or 5 characters? Well, the coder can't just tack that 7th character onto the end. It has to literally sit right there in this 7th position. So the coder uses this placeholder X to bridge the gap. It fills the empty spaces in this highly structured language just to ensure that final character lands exactly where the computer systems expect it to be. Pretty clever, right? Next up, let's look at how these pros handle the inevitable gaps between cutting-edge medical science and the printed codebook. Because what happens when a physician is incredibly detailed, documenting a super specific, maybe rare variation of a disease, but the codebook just hasn't quite caught up yet? Well, the coder relies on the NEC convention. That stands for Not Elsewhere Classifiable. This essentially translates to Other Specified. It's basically telling the insurance company, hey, the doctor gave me great specific details, but the manual doesn't have a unique code for this yet, so we're putting it in this other category. On the flip side of that, we have NOS, or Not Otherwise Specified. Think of this as the equivalent of unspecified. So if a doctor just scribbles down pneumonia without actually identifying the specific bacterial or viral cause, the coder is kind of stuck. They cannot guess. They absolutely cannot assume facts that aren't written down. So the coder must use an NOS code, which essentially translates the documentation exactly as vaguely as it was written. It's a built-in protective mechanism to maintain the pure integrity of the medical record. Now, to keep the whole system streamlined, ICD-10 uses what are called combination codes. This is where the grammar gets super efficient. It allows a coder to bundle complex, intertwined medical conditions into a single elegant string of characters. So instead of assigning one code for a disease and then a totally separate code for the secondary complication it caused, a combination code just wraps both elements together.
Coders are actually instructed to always use a combination code when it's available, rather than multiple separate ones. It just paints a much clearer, more concise picture of the patient's health.
All right, Section 3, inpatient versus outpatient. Let's see how this whole grammatical system actually shifts depending on the environment where a patient is treated. Because, as you'll see, the rules for a quick clinic visit are fundamentally different from the rules governing a 2-week stay in a hospital. The financial machinery operating behind the scenes here contrasts really sharply between these two settings. In an outpatient setting, like your standard doctor's office, billing totally revolves around what the physician actually did. You know, the procedures, the tests, the time they spent. Those are captured using CPT or HCPCS codes, which are often referred to in the industry as the money codes. In this case, the diagnosis just justifies the procedure. But for inpatient hospital stays, that paradigm flips completely upside down. Hospitals are paid for their hospitality, literally housing, feeding, and nursing a patient back to health. This payment is calculated using a really complex formula called an MSDRG, and that formula is driven entirely by the severity of the patient's illness. So suddenly, in a hospital setting, the diagnostic codes become the money codes. And because those diagnostic codes drive the hospital's reimbursement, accurately selecting the principal diagnosis is absolutely paramount. This is defined as the condition established after study to be chiefly responsible for admitting the patient in the first place. Notice that after study part, it's not necessarily what they thought the problem was when you rolled into the ER. It's what they ultimately determined the problem was after running all the tests. Accurately sequencing this principal diagnosis first is literally the most critical step for triggering the correct hospital payment.
Okay, finally, Section 4, the coder's mindset. To really thrive in this kind of high-stakes environment, it takes a very specific type of professional to navigate these relentless rules day in and day out.
Honestly, being a medical coder is essentially a team sport played by curious, incredibly detail-oriented detectives. First and foremost, they have to treat patient privacy as absolutely sacred. Under HIPAA rules, viewing medical records with total discretion is non-negotiable. But beyond that, they are constantly analyzing complex operative reports, abstracting tiny clues, and hunting down missing information. And since medicine and federal guidelines are rarely just black and white, they frequently have to collaborate with their peers or directly query physicians to decipher all those tricky gray areas. Add to that the fact that coding guidelines are updated by the government every single year, and you've got a profession that requires immense, constant adaptability. And as this quote perfectly highlights, because medical science is just continually evolving, a successful coder's education is never truly finished. With brand new diseases and cutting-edge surgical technologies popping up all the time, coders literally have to continuously update their knowledge base just to navigate an ever-expanding classification system. So, after all of this, it kind of leaves you wondering, doesn't it? Just how many complex rules, combination codes, and placeholder X's were used behind the scenes the last time you visited the doctor. Behind every simple copay and every confusing insurance statement is a dedicated professional rigorously translating your personal health journey into the secret universal language. I bet it makes you look at your next medical bill in a whole new light, for sure. Thanks so much for learning with us today. Keep questioning the world around you, and we'll catch you next time.